This video is to do a review of Chapter 12 from the Lehamann text. This review is for Math 120 at Kenyatta College. So we're going to start off with finding the domain of a rational expression. In finding the domain of a rational expression, the most important thing is the denominator of that rational expression, because the domain is based upon the restrictions to the set of real numbers, the numbers for which this rational expression would become undefined. So we're going to focus our attention on the polynomial x squared plus 7x plus 12. And what we're going to do is apply the zero factor property to this so that we can find out where the zeros for this polynomial are located. And that means that we're going to take the polynomial and we're going to set it equal to 0. Once we've set it equal to 0, we'll factor it if possible. And the factors of 12 that give me a sum of 7 is what I'm looking for. So we're going to have an x with a 4 and an x with a 3, because 4 times 3 is equal to 7, and 4 plus 3 is equal to 4 times 3 is equal to 12, and 4 plus 3 is equal to 7. And so what we have here is the fact that we have a sum, and then the sum is a positive sum. That tells us that both of these must be positives. Now that I have it factored, I'm going to set each of these factors equal to 0. That's called the zero factor property. If we have a times b equal to 0, then a must be equal to 0 or b must be equal to 0. Now we're going to solve these very, very simple linear equations by setting them equal to 0 and solving. And so what we're going to get is x is equal to negative 4 and x is equal to negative 3. So either x being a negative 3 or x being a negative 4 is going to be a possibility to give me this denominator being equal to 0. Therefore, that is what we're going to restrict from our domain. So capital D, standing for domain, are x's such that x doesn't equal either a negative 3 or a negative 4. Now remember that when we use this type of notation called set builder notation, what we're looking at here is that we have the set of all real numbers. That's always assumed, and so we're saying that the set of all real numbers excluding negative 3 and negative 4. All right, that concludes number 1. Now we're going to move on to number 2. So problem number 2, we're looking at, problem number 2, we're looking at simplifying a rational expression. Simplification of a rational expression is yet another application of factoring. So what we're going to do is we're going to factor both the numerator and the denominator of the rational expression so that we can see the common factors so that we can cancel them. Up here in the numerator, what I have is a 4-term polynomial. So I'm going to attempt it by factoring by grouping, because that's how I attack 4-term polynomials. So my first two have an x in common, so I'll take that x out. And when I divide x out of x squared, I get simply an x. And then when I divide x out of xy, what I am left with is a y. Now, keeping in mind this x plus y here, when I look at these two, I notice they're both negative. So I'm going to take out a negative number so I can make them both positives. And they both have a 4 in common, so I'll take out that 4. So when I take out a negative 4 from the first term, that leaves me with a positive x. And when I'm taking out a negative from the second term, that leaves me with a positive as well. And when I take out 4 from 4y, that leaves me with y. Now there's one more step, because now again I have two terms here, and I'm looking for these two terms what I have in common. And what I have in common is the binomial GCF x plus y. So like all GCFs, I write it down. And notice it doesn't have a squared on it or anything else. It's just that GCF written down once. And then I'm going to go back here and I'm going to say, okay, if I took that out, then I'd be left with x. And then this is subtract, so get the subtraction in here, and if I took it out, I'd be left with 4. So there we go. That's what it looks like. Now moving on to the denominator, I'm going to switch colors because it'll hopefully help us see things a little bit clearly. This is a trinomial, and I see a leading coefficient of 1. which is really good because that means I can focus my attention on 4. And I need the factors of 4 that give me a difference of 3. Well, that would be 1 and 4. So I notice also that there's a y squared in the last term and there's a y hanging around in here, so there will be a y with these factors as well. So my binomials are going to look like an x with a 1y and an x with a 4y. And then I need to talk about signs. Since how this is a difference, right, a subtraction here, that means I'm going to subtract the factors of 4 and 1 to get 3. And I need a negative 3, so that means the bigger factor, 4, must be negative and the smaller one must be positive. And now I'm just going to carry this on over here because I didn't have any more factoring to do. Once I have a product, I've factored it, and so I know I'm done. So I have x minus 4y here. And now I'm going to cancel as much as possible. So my x plus y is in common both in top and bottom, so I can cancel it. And now, when I'm all finished, all I have left is an x minus 4 in the numerator, and in the denominator an x minus 4y. Now notice there's no more canceling. These things are sums. There's no canceling in addition. You can't cancel that 4 and that 4, that x and that x, because they're added to one another. Just try that with something like 2 minus 7 over 2 minus 14 if you have any doubts about whether you can cancel or not. Try it. Cancel them out and then see what you get, and then do it using order of operations and see what you get. And you'll see that there is no canceling in addition. All right, now moving on to our next problem, we're going to do some, oops, it skipped again. We're going to do some addition and subtraction of, we're going to do some simplification of complex fractions. So in this, I have a very complicated numerator and a very complicated denominator. They involve fractions and addition and subtraction of those fractions. So I'm going to use a least common denominator in order to simplify these. Before I begin, I need to factor as much as possible. This right here really should be written as minus y squared plus 9, which shows me that this really should have a negative 1 factored out in front, so that I'd get a y squared minus 9. Now once I have that, I can further see that this really looks like y plus 3 times y minus 3. So that is going to be my factors here. Now looking down to this term as well, I see that's not ordered as well. So this really should be written as negative y plus 3 because that's an order. But that shows me that the leading coefficient is negative, so I'm going to factor out a negative, getting a positive y and a negative 3. Now, once I have all of these, I'm looking at that as my denominator, that is my denominator, this is a denominator, and this is a denominator. So looking at all of these, I'm going to need the least common denominator. And my least common denominator for all of these, my LCD, is going to be a positive, because this and this I'm actually going to use to make this an addition, and also as this as an addition, and so I won't have any negatives in them. I have a y minus 3 and I have a y plus 3, and that's going to be my least common denominator. Now what am I going to do with my least common denominator? Well, I'm going to multiply it, and I'm going to multiply this by the top of the fraction and the bottom of the fraction, the fundamental theorem of fractions. And when I multiply, these are complicated, so it's going to distribute. So it's really like both the numerator and the denominator, each term getting multiplied by that LCD. So multiplying by LCD here, multiplying by the LCD over here, multiplying by the LCD down here, and one more time right here on this one. Now, when I multiply by these, I'm not multiplying them out, I'm multiplying to cancel. So that y minus 3 term cancels with that y minus 3 term, leaving me with 5 times y plus 3. So I'll write that down. and then plus, and then the y minus 3 and the y plus 3 cancel here, leaving me with simply a 4. And then in the denominator, the y minus 3 cancels with the y minus 3, leaving me with 3 times y plus 3. And then plus, and then here the y minus 3 cancels with the y minus 3, leaving me with y plus 3. And then, now remember there was a 1 there, so it was y plus 3 that I got left with. All right, now I need to expand this numerator out. So the 5's going to distribute here and here, so I'm going to get 5y plus 15 and then plus 4. And then in the bottom, the 3 is going to distribute out, so I'll get 3y plus 9 plus y plus 3. And then on the top and the bottom, I need to combine the like terms in each. So here we can combine the constants, so I'm going to get 5y plus 19 in the numerator. And then in the denominator, the 3y and the y will add together to give me 4y. And then the 9 and the 3 will add together to give me 12. Now the last thing I should always do is to check to see if things can factor and cancel. So you can't check for factoring and or canceling unless you factor, so I expect to see that you factor this. There is a common 4, so that would leave me with 4 times y plus 3 in the denominator, and 5 and 19 have nothing in common, so it would be 5y plus 19 in the numerator. Now what you should notice is that there's nothing going to go and cancel here, so this can be left as your final answer. Now some instructors and some books will want you to move it back over here to where it was all expanded out. I figure best case scenario, you can always do that. So just box this as the final answer for me because I want to see proof that you really did factor and that you really did check to see if that canceled. All right, moving along to part B. I think part B personally is a little bit easier of a problem because these denominators down here, I'm going to use the same technique as before, but these denominators are just monomials instead of binomials. So my least common denominator is going to be a lot simpler. Numerically, 2, 6, and 2 all have a 6 as a least common denominator because 2 is a factor of 6. And then there's a y. So my least common denominator is going to be 6y. So I'm going to multiply every single term by that 6y. 6y times each fraction, both in the numerator and in the denominator. Remember, it doesn't even have to be a fraction. If it weren't a fraction, you'd still multiply it as long as it were a term within the numerator or denominator. Now my next step is to cancel. So 6 cancels with 6. Y times y is y squared. And then minus, and then 2 goes into 6 3 times, and the y's cancel as well, so that's y squared minus 3. Then the next one, the 2y cancels with the 6y and just leaves 3, so this looks like 3 minus, and then the y's cancel, and that one's going to give me just a 6, so that leaves 2 numbers in the denominator. So y squared minus 3 doesn't simplify. And then in the denominator, 3 minus 6 is a negative 3. And that's a little inconvenient to leave a negative out there or down there in the denominator. So I'm going to put the negative out here in front. And then I'm going to write y squared minus 3 in the numerator. And I'm going to write a 3 down here in the denominator. Now, this 3 and this 3, remember, there is no canceling in addition. All right, I'm going to end for now. I'll come back with another video.